In this video, we're going to look at an example that we have a random set of 244 people who have pets that were polled to see if there was a correlation between gender and then whether or not they had a cat or a dog. And then we have this contingency table here that shows all the data from the survey. F is going to be the event that the person picked was female. M is going to be that the person was male. C is going to be that they owned a cat. And D is going to be that they owned a dog. And we're going to find the following probabilities. Okay, so for part A, it says, what's the probability that the person chosen was a male and owned a cat? So if the person was male and owned a cat, we're looking to see where that overlaps. So right here, it shows all the people that were male and owned a cat. So that's going to be 29 out of 244, the total. So we're going to do 29 divided by 244 for part A. And then, of course, when you divide, you'll get your decimal value of 0.1189. For part B, it says, what's the probability that the person that was chosen was a male or that the person owned a cat? So when you're doing an or statement, you want to use the addition rule where you take the probability of the first event and you add it to the probability of the second event. And then if there's any overlap, you subtract that off. So we're going to find the probability of being a male. So if we look in the chart here, out of all of the people, there's 117 that are male. Then if we look at all the people that own a cat, that's this group here. So that's 112 out of 244. So I'm going to take 29 over 244. That's the probability of being a male. And then, whoops, I meant 117. Okay, so 117 for male out of 244, and then the probability of owning a cat was 112 out of 244. But if you notice, when we counted up these probabilities, there was one group that we counted twice. This 29 overlaps in both categories. I counted that group of 29 when I counted males, and then I counted that group of 29 when I counted the people that own cats. So I counted that group of people twice. So I want to make sure that I only count them once. So that's the overlap. I'm going to subtract off 29 divided by 244. So for part B, I'm going to take and put in on my calculator 117 divided by 244 plus 112 divided by 244. And then I'm going to subtract the overlap, which is 29 out of 244. Now, what you should get when you do that arithmetic on your calculator, you should get 0.8197. For part C, this is the case where you have a given assumption. We're looking for the probability of choosing a male, knowing that we're picking it out of only the groups that own cats. We're making the assumption that we've already picked a person that owns a cat. So that second value here is our assumption. We're finding the probability that the person is male given that we picked someone that owned a cat. So we're going to only look at this column here. If we know that the person we're picking owns a cat, and we want to find the probability of out of that group, we want to find the probability that the person is a male, then our probability is going to be 29 out of 112. And then when you put that in on your calculator, you should get 0.2589. All right, now looking at part D, let me erase this. Now looking at part D, we're doing it in reverse. We want to find the probability of picking someone that owns a cat out of the group of males, because we're making the assumption that the person we're picking is male. So we're looking at the given assumption. These are all the people that are males, 117, and we want to look to see out of this given group how many of them own a cat. So that's going to be the 29 out of 117. And then when you put that in on your calculator, you should get 0.2479. For part E, it says find the probability that the person owns a cat. Now this one's nice and simple. There's no extra assumptions. We're just looking at the number of people that own cats out of the total. So for part E, that's going to be the number of people that own cats is 112 out of 244. When you put that in on your calculator, you're going to get 0.459. Now, for the last part, part G, actually, that should be F. That's a typo. I just noticed that. But anyways, for that last part, we're doing the complement of C, which means it's going to be the probability of not owning a cat. So that would be the people that own a dog. So that's going to be 132 out of 244. Or another way you could write it is you could take 1 minus the 0.459. Either way, you'll come up with the same answer, which is 0.541.